The purpose of this video is to help you better understand the way the shape of your data will impact your measures of central tendency, mean, median, and mode. Let's start off by pretending we have a seesaw. And the key to this is that numbers have weight, in a sense. So I want you to remember that and think that way. And many students find it helpful to think about numbers as having weight, just in this unit at least. So let's pretend we have some babies or small toddlers, and we put them on a literal seesaw. And one weighs 10 pounds, one weighs 12 pounds, one weighs 14 pounds. So the balance point is 12. That's right here in the middle. And that's where that fulcrum is, or that balance point. So that's the mean, but that's also the median. And that's because 12, if these numbers are lined up in order, and 12 comes right in the middle. So we have mean of 12 and median of 12. But what if this third baby doesn't weigh 14 pounds? This third baby weighs 40 pounds. This shifts the balance point from 12 to 21. So now the new balance point is over here. And you can probably see that in order for this seesaw to balance, we have to shift the fulcrum, or the balancing point, over more toward the 40 pounds because we have more weight on that side. So if you think of numbers as having weight in a sense, it will help you understand a little bit about what happens to the mean when the shape of the data has changed. So this data set became elongated out toward 40 as we added that 40-pound person versus having the 14-pound person. Now you'll notice that the median here is still 12. And actually, usually if you have more than just 3 observations in your data set, that median will shift a little bit, but it doesn't shift as much because it's not concerned with trying to balance out the weight of the numbers. Numbers have weight, in a sense, and the mean is trying to balance out that weight. The median is not trying to balance out the weight, it's just trying to balance out the number of people on the seesaw, if you will. So in that case, it doesn't really matter how much this third person weighs, because 12 is still the middle person. So the median is just balancing out the number of people on the seesaw. The mean is balancing the weight of the numbers. So with that, we move to the shape of the data, and I've made some data sets over here that have different shapes. The first one has left skew. You can see it here. The second one has right skew. And then the third one has no skew over here. So what skew means is simply that the tail of the distribution is elongated in the direction of the skew. So if we say left skew, it means the tail is elongated off toward the left. If we say we have right skew, the tail is elongated off toward the right, like you see here. And a lot of students say, oh, skew is sort of where we have this cluster of data, where we have the most data. Sort of like bias, this is where the most data points come in. And they describe it with some of this terminology. So in order to prevent that, make sure you're not thinking of it that way. Make sure you're focused on the tail. And to help you do that, here is a shrew with a long tail. And if you think of skew and shrew, and you think of that long tail, that's what we're interested with skew, is in which direction is the tail elongated, the tail of the data. Is it pulled off to the right or to the left? Or do we have no skew, as is the case here? You can't say that the tail is pulled or elongated one way or the other. Now another shape issue is kurtosis. And this refers to the peak of the data. How tall is the peak? Or how flat is it? Is there not much peak? That's kurtosis. If you have more kurtosis, you have more peak. And if you have less kurtosis, it's flat. So if you think, in order to put the toes in kurtosis, I give you this drawing, and you can think of looking down at your feet, and the big toes, the most peaked toes, are in the middle as you're looking down at the feet. Now, of course, there are exceptions. My second toe is the longest, but for the most part, you can think of the peak being in the middle, and when you think of toes, you think of kurtosis, and you think about how peaked the middle of the the data is, how peaked this distribution is, or how flat it is if there's little kurtosis. Now to bring this all home, and this is what the video is really all about, is how that shape impacts your measures of central tendency, mean, median, and mode. And it turns out that with kurtosis, it kind of brings things more to the middle usually, but we're going to forego that for now because it's a little bit more involved, but just keep in mind that we can talk about kurtosis having an impact on our statistics as we get into that later. But let's focus on skew. So I have lines here, mean, median, and mode, and I place them over each of these different kinds of data shapes. And if we have no skew, and this is very important, if you have no skew, the mean, median, and mode are lined up right in the middle. If you have left skew, the mean is the most impacted, so it moves farthest to the left. The median is the second most impacted, and mode is not impacted as much at all. So the mean is impacted because it's trying to balance the weight. And when that tail is elongated off to one side, it has to move out to try and balance out the extra weight that's out there. The median does shift, but only based on the number of extra observations that are off in that direction. It's not also trying to balance the weight of the numbers. So a good way to see this is if I take 3 people off the street and ask them how much money they have in their wallet. Maybe the first person has $10, the second person has $20, and the third person has $30. So the mean is 20 in this case, and the median is also 20 in this case. But if I replace, or let's say I bring in a 4th person, okay, and that 4th person happens to be Bill Gates, and he has $250,000 in his wallet, which I hope he doesn't carry around. So we can do a little Excel magic here, and we now see that the mean is $62,515. But so before we had mean of 20 and median of 20, now we have mean of 62,000, and the median, now we have an even number data set, so the median is right between 20 and 30 at 25. So the median shifted by 5 just because we have an extra person. So it has to move over a half step to account for that extra person. The median is trying to balance people. But the mean is trying to balance the weight, and that 4th person brought in a lot of extra weight. So they're shifting even farther in that direction. Now in order to remember this, I find that students struggle to remember how does the shape of the distribution impact the relative positions of mean, median, and mode. All you have to do is remember mean, median, and mode in that order. And in this course, I very deliberately always presented those 3 in that order, mean, median, and mode. And again, that's very deliberate because if you have left skew, you start from the left and say mean, then median, then mode. So in left skew, mean is farthest to the left, then median, then mode. In right skew, again, it's mean, median, and mode, but starting from the right. So you just start in the direction of the skew. The mean goes first, then the median, then the mode. And if you remember that, you'll be in good shape. If some of these things don't work for you and you have a better way to think of it in your mind, share that on the discussion board where like-minded students can benefit. And good luck.